Hello everyone. So in this lecture we will be starting with a new chapter called vectors, and the notes for the lecture will be available below the video in form of a Google Drive link. Let's continue. Um, we'll start by differentiating between two quantities called scalars and vectors. So scalars are quantities which only require a magnitude to specify them. So in your 9th and 10th standard you might have seen many quantities which are scalars. For example, speed, time, temperature. So assigning a number to these quantities, maybe position. So assigning a number to these quantities will give you the complete description of the physical quantity we are talking about. So they are generally represented by a magnitude or a number. On the other hand, vectors uh, are represented by a magnitude and a direction. So some quantities you might have learned in your class 11th, like or 10th, velocity, acceleration, force, the or electric field. These quantities require a number and a direction to represent them. Uh, some other examples of scalars can be energy or work. Okay, so let's continue from NCERT and give some basic definition. So let's see. So there's a definition. Okay, so here's a definition. Quantity which has magnitude as well as a direction is called a vector. So let's talk about representation of a vector. So vector can be represented using an arrow. So first how we can draw a vector. So this arrow can represent a vector. So length of the vector will represent the magnitude. So length will represent magnitude. Of course, this line can have two directions. This uh, facing this words in this direction or this direction. And the direction will is represented by the where we are drawing the arrow. So this arrowhead represents the direction. So this is how we can draw a vector. We can draw a straight line and we can draw an arrow, or we can represent a vector by naming it. We can give the initial point the name A and the final point the name B, and AB vector. So it is a vector joining. So starting from initial point A, vector starting from initial point A to final point B. So of course there is a BA vector also, right? So this vector will start from B and end at A. So let's say this is B and this is A. So B, A. So we will start a line from B and end at A, and we'll draw an arrowhead at A. So this here represents the BA vector. So it is equal in length, but it has the opposite direction. Okay. So in that sense, we can define AB vector is equal to negative of BA vector. So they have AB vector and BA vector have same magnitude. Basically, they have the same length, have same magnitude, but opposite directions. So this was the second way in which we can define a vector by giving an initial and the final point. So this was the first method, you can draw it. Second method, you can define an initial and final point. And the third one is we use lowercase alphabets. So let's say I can define a vector, b vector example. So if I have this vector, I can simply name it as some vector v also. So let's say v vector. So there can be an initial point and final point. So we can define AB vector is same as v vector. So here v is a small. So generally we stick to small letters. So for example, I can define r vector. So let me call it r. Okay. So this is a we have to use this lowercase alphabets here, or you can use initial and final point, where initial and final point will be represented using capital letters. Okay. So let's go back to our NCERT and let's define more things. So okay, so magnitude of a vector which is basically the length of the vector. This is represented by uh, putting bars around your vector. So AB vector or some R vector. So this is just a scalar. This is a scalar. This is a scalar quantity bit because it only tells you the length or just the number associated with the vector. It does not tell you the direction of the vector. So this quantity is a scalar. So modulus is a scalar. Magnitude of a vector is a scalar. Okay. So let's go further. Let's see. Okay. So first they have defined as a position vector and also the direction cosine. So let's go into that discussion. So what is a position vector? So let me vaguely define. So position vector is same as coordinate of the point. But let's see. So we have all done three-dimensional geometry in our class 11th. And let me define few axes x, y, and z. And let's say there is a point P which has coordinates x, y, z. So vector associated with P, position vector of P will be a line or it will be a vector that will join the origin to the point P. So, uh, so let's say this one, and this is point P. And let's say origin is O and its coordinates are 0, 0, 0. So OP vector is a position vector of point P. And even though we have not defined I cap, j cap, k cap and how to write down a vector, we can still find the length of the OP vector, because we have done coordinate geometry in third three-dimensional geometry in class 11th, and we know the length of this vector is nothing but given by, it is just given by distance formula, x minus 0 square, y minus 0 square plus z minus 0 square. So length of the OP vector is nothing but root of x square plus y square plus z square. Okay. So this was nothing but the extension of the Pythagoras theorem, if you have done it correctly in class 11th. Let's continue. Let's see. So now they have defined direction cosines and the relation between the direction cosines, which will be very useful in the even in the three-dimensional, even in the next chapter, which is three-dimensional geometry. So uh, let's define direction cosine now. So what are direction cosines and what is the relation between them? So let me draw three axes, z, y and x. So x, y and z, and let me define a point P which has coordinates x comma y comma z. So direction cosines are basically given by three angles, alpha, beta and gamma. So alpha is the angle with x axis, and similarly beta is the angle made by the vector with y axis. So please write just y axis, and gamma is the angle made by the vector with z axis. So alpha is this angle, so it is the angle made by the vector with the x axis, so this is alpha. Beta is the angle made by the vector with the y axis, and gamma is the angle made by the vector with the z axis. Okay, so maybe I can draw gamma a little bit here or there. Okay, so gamma. So uh, so why are they called direction cosine? So basically we have to define cos alpha, cos beta, which are basically cosines, and cos gamma, and in short form we also call them L, M and N. So this is just a notation. So cos alpha is known as L, cos beta is known as M, and cos gamma is known as N. Okay, so what is cos alpha? So if we go back into this diagram, and if I rub a few things off and I try to define what will be cos alpha, so let me draw a perpendicular from that point on the x-axis, and let me call this as origin and this as, let's say, so this point is on x-axis, let me call it x. So in triangle POX, cos alpha, so what is cos theta? Cos theta, if you remember from class 10th, is based by hypotenuse. So in triangle, so with respect to alpha, the adjacent side is OX and the hypotenuse is OP. So cos alpha is nothing but, so OX. So what is the length OX? So this is basically the x, and OP is root of x square plus y square plus z square. So why I have defined this as x? So this length is small x, which is basically the x coordinate of the system. So this is nothing but the projection. So OX is just nothing but the projection of OP on x-axis. You can take a simpler example in two-dimensional geometry. You can draw a vector here, and so if this point is x comma y, if I draw a perpendicular on x-axis, so this coordinate will be x comma 0, right? So similarly, this coordinate will be x comma 0 comma 0. So of course that length is going to be x because it is measured from the origin, which is 0 0 0. And if you draw the perpendicular on y-axis, you will reach the point 0 comma y. And of course, so let's see. So in similar way, you can define also angle with the y-axis. So you can drop a perpendicular from point P on y-axis, and you will reach the point 0 comma y comma 0. And this, let me call this as y. And in triangle OYP, you can see this length is small y. And this length we already know, we have defined it using distance formula, x square plus y square plus z square. And then similarly, I can define cos beta. Similarly, is y divided by root of x square plus y square plus z square. And cos gamma, so cos gamma is z divided by root of x square plus y square plus z square. So what is the relation between direction cosine? So the relationship goes like L square plus m square plus n square is 1, or if you remember, L was nothing but cos alpha, so cos square alpha plus cos square beta plus cos square gamma is 1. So let's prove this. So LHS is L square plus m square plus n square, which is cos square alpha plus cos square beta plus cos square gamma. And cos alpha is nothing but x divided by root of x square plus y square plus z square. And we have to square this, and y divided by root of x square plus y square plus z square. And square this plus z divided by root of x square plus y square plus z square. So they all have the same LCM, and the LCM is x square plus y square plus z square. In the numerators, I have x square and then y square and z square, and all of this cancel up, and we get 1 as the result, which is the RHS. Okay, so we have this important result on the direction cosines. So just remember, alpha is the angle made by the vector or the point with uh, with x-axis. So, and beta is the angle made by the vector with y-axis, and gamma is the angle made by the vector with the z-axis. So let's continue our discussion from NCERT and define uh, some some types of vectors uh, which are given on this page. Types of vectors. So let's start with a zero vector. So what is a zero vector? So a zero vector is a vector whose initial and terminal points coincide. It's called a zero vector or a null vector. It is denoted, so okay, so if I have a point A and my vector starts at point A and ends at A, so it has basically, we cannot define the direction of the vector, right? It can be here, 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 because we are not actually going from a point to point. So A vector, so initial point is A, final point is A, is basically a null vector, okay, and the length of the null vector is 0, okay. So, and one thing that they have mentioned here is uh, it may be regarded as having any direction. So direction is not defined for a null vector. So direction is not defined for a null vector. Let's move further into our discussion and let's see more examples from the NCERT. So next is the unit vector. In this section, let's see unit vector क्या होता है. So unit vector is a vector. So maybe you can, but it has a, instead of writing a vector, we put a cap on it, or a vector. So a vector. But a cap. So the cap represents it's a unit vector. So unit vector has a property that its length. So if it's a unit vector, length is 1. So any vector which has length 1 is a unit vector. A cap has length 1. So if I draw this vector AB, and if this length is 1 unit, then it's a AB vector is a unit vector. And instead of putting a vector sign, you should mostly put a cap sign on it so that we know it's a unit vector. Let's see next. So co-initial vector. So if two or more vectors have same initial point, then this is called a co-initial vector. So let's say this is some point A, and from this I have a vector that starts from A and goes to B, and if I from A I also have a vector that goes to C. So these two vectors originate from the this point A. There can be third one also, nobody is stopping you there. So D. So I can say AB vector, AC vector, and AD vector are co-initial because they start from the same point A. They have the same starting point A. Wherever they can end up anywhere, they can have any length, but only thing is they start from the same point. Okay. So for example, in a drawing, you can be asked, are these two vectors co-initial? Or let's see, if I name this point as A, B, C, D, and so of course AB vector is not co-initial because AB vector is starting from point A, right? This is the initial point for AB vector, and B is the final point. But there are two co-initial vectors in this, right? BC and BD, right? They start from the point B, are co-initial. But AB is, and let's say BC, right, are not co-initial, are not co-initial. Okay, so hopefully that is clear. You have to just check where do these vectors start. Okay, so let's go to next definition. Collinear vectors. So collinear vectors are those vectors which are parallel to each other. So they don't need to be in the same direction. They don't need to have the same length. For example, this vector, and this vector. Let's say I can change the length of the third one. Let's say this. I can call this as A vector, B vector, and C vector. So forgive my drawing, but let's say these are all parallel. Okay. So A vector, B vector, C vector are collinear vectors because you can read the definition. have to be parallel. Okay? So there is no talk about their length or their direction. Okay? So they can have different magnitude, or they can be even in opposite in direction and can be opposite in direction. Okay. So moving further. So now there's a definition of equal vectors. So two vectors are equal only and only if their lengths are same and their directions are same. So you can draw the second vector anywhere, but only constraint it has, let's say this is A vector and this is B vector. So they are equal only and only if they have the same magnitude and direction. So mod of A should be same as mod of B, and so this is the magnitude, right? They have same length, but they also should have same direction. A vector and B vector also should have same direction. Should have same direction. So just by saying, so let's say a small question. Let's say if mod A is equal to mod B, then can you say that two vectors are equal? So are A and B vector equal? The answer is simply no, right? The answer is no. And why is that? Because let's say this is A vector and this is B vector, so they have equal length. So of course, in this case, mod A is equal to mod B, but what is not same? But A and B do not have same direction. A vector and B vector do not have same direction. Okay. So let's move further into the definitions. Let's define the last definition, which is the negative of a vector. Okay. So maybe we have already defined that, right? So AB vector is given by a vector starting from A ending at B. So arrowhead should be at B, right? And this is the AB vector. And of course, if you want to draw BA vector, you can draw a vector of equal length in the opposite direction. So it starts from B but ends at A, right? So this is BA vector. And here we define as AB vector is negative of BA vector, although their lengths are same. Okay? Mod of AB is equal to mod of BA, but they have opposite direction. So negative of a vector. So uh, so if A vector and B vector are negative of each other, then you should simply check for if mod A is equal to mod B, and first and second A and B vector have opposite direction. If they have same direction, of course they are equal vectors, right? If A vector and B vector have opposite directions. So we can now move into the examples and complete our first exercise. So we have an example 1 from NCERT. So it says represent graphically displacement of 40 kilometer 30 degree west of south. So Okay, so hopefully you know what is north of uh, what is west of north and east of north. So let's see, but I can give you example. Let's say this is your compass, um, north, south, west, east. So let's say um 50 degree east of north. So to represent this, you will draw 50 degrees angle from north towards east, and maybe this is 50 degree, and so this direction itself represents uh, 50 degree east of north. So let's go into this example. Uh, so to do this example, I will draw my origin and xy axis. So probably I can do it a little bit cleaner. Um, okay, and then we have to do 30 degree west of south. Okay, so let's mark our directions: north, west, south, east. 30 degree west of south. Okay, so we have to draw 30 degree from south and towards west. So this should be the direction, and maybe I can draw an arrow here. Maybe a little bit cleaner. Okay, so let's say this angle is 30 degree and this length is 40 kilometers. So this can be a good representation of this question. Let's say NCERT solution should be similar. Okay, so if you want, you can of course draw um, scale also, but yeah. So we'll define this this as origin and this is the final point P. So this OP vector represents displacement of 40 kilometers and direction is given by 30 degree west of sun. Let's move to next question. Oh, so this one is example 2. Classify the following measures as vectors or scalar. Should check the next page also if there are more. Okay, so there are more. So I'll insert them also here. Okay. So 5 seconds. We know time is a scalar. We do not need to define. We do not need to give a direction to define time. So this quantity here is a scalar because let me mark the quantity because it is time. So centimeter cube, it's a volume. Volume is also a scalar. 10 Newton. So this is a force which is a vector. 30 kilometers per hour. So it's a representation of speed because no direction is given. So it's a scalar. So gram per centimeter cube is the representation of density. So uh, density is a scalar. You do not need a direction to define density. It's a scalar. It is density. But now last case, so 20 meters per second, towards north. Okay, so this here is a vector, and it is not speed, right? It is velocity, because speed with direction is known as velocity. Okay, so let's go to into third example and take the figure also. Okay, so in this figure, which of the following are uh, collinear, equal, and co-initial vectors? So first part, so which of these are collinear vectors? So collinear vectors, what was the definition for collinear vectors? So as you remember, collinear vectors are those vectors which are parallel. That is the mainly definition, parallel or anti-parallel. And we have no restriction on their lengths, right? So remember the diagram, right? This or this one, right? These are collinear vectors. So if you look into the diagram, A vector is parallel to C vector. Okay, so A vector is parallel to C vector, and C vector is anti-parallel to D vector, and A vector is also anti-parallel to D vector. So you can see I can mark these with red. So so A vector, C vector, and D vector. So these are in the same or opposite direction, no restrictions on length. Okay, so these are collinear vectors. Second part of the question is, which of them these vectors are equal vectors? So equal vectors has a definition: same magnitude and same direction. Same magnitude and same direction. So if you look carefully in the four vectors given, A, B, C, D, only A and C have equal length, and they are also in the same direction. So of course B and D also have equal length. They are of 3 units, but they do not have the same direction. So I will mark here A and C vectors are equal vectors. They are equal, and the reason being, they have same magnitude, they have same length, and they are in the same direction also. And B and D, even though they have same length, are not equal, right? Are not equal. They have different directions, right? So third part here is co-initial vectors. So what are co-initial vectors? So if you remember our definition, co-initial vectors are those vectors which have the same starting point. So the figure must look like something like this. So let's say this is our starting point A, and they can end up at B, C, or D. Okay, so let's go at our figure and let's figure out if there are any co-initial vectors. Okay, so if I look carefully at this point, so only A vector starts from this, B vector is in the opposite direction. But if I look at this point here, so B vector, C vector, and D vector all start from that point. So I will say B, C, and D are co-initial vectors because they start at same point. Okay. So B vector, C vector, and D vector are co-initial vectors. So let me correct that. Co-initial vectors because they have same initial point. So that concludes our examples, and we can go through our exercise 10.1 really quickly. So, okay. So 40 kilometers and east of north. So north, east, and 30-degree east of north. Okay. So from north, I should draw 30-degree angle. And if by scaling this is 40 kilometers, so this OP vector is a vector. OP vector is, या फिर it represents displacement at 30-degree east of north. So we start from north, we draw 30-degree angle towards east, and this is 30-degree east of. Okay, so which of these quantities are scalars and which of these are vectors? So let me name them quickly. So first is 10 kg, which is nothing but weight of the object or the mass of the object. So this is nothing but a scalar. Second is 2 meters northwest. So of course northwest is 45 degree from north or west. So we have a direction also, and so this is a displacement. So this here is a vector since it is a displacement. Third question is 40 degrees. Okay, so 40 degrees. So if you have a D, right, and if you want to draw 40-degree in it, so maybe it will come out somewhere here, right? This is 40-degree, but this is only direction, right? Okay. Only direction. So there is no information about the length of the vector, so it is only a scalar. So we can check that from the backside. You can check that from the backside of the book also. This is only a scalar. This is only a number which gives the direction only. So what was the temperature or something? Degree Celsius or something? But degrees. Okay, so now 40 watts. So fourth part is 40 watts. So if you remember, watt is a unit of energy and which is a scalar. You do not need a sense of direction while calculating the energy. So this is a scalar since this is energy. Fifth, so what is power? I'm sorry, power. Watt hour is energy, right? So this is power, and for calculation of power, you do not need uh, a direction. So it's a scalar. So fifth case here is 10 to the power minus 19 coulombs, which is a charge, and charge is also a scalar. So charge can be added and subtracted, and it's added without a sense of direction. Uh, then 20 meters per second square. So this is acceleration, but it does not specify the direction, so we will call it a scalar. If it said 20 meters per second, towards north, then we have the direction also, but this here is just a scalar because there is no talk about the direction. Moving further to the next question. So is time period a vector or a scalar? It's just a scalar, it's just a number. It is the time interval. So we start the clock at some point and end at some point. It will give you a number, not the direction. And distance is also scalar because we do not talk about the direction when we are talking about distance. So force, velocity, work done. So force we know is given by magnitude and also the direction in which we are applying it. So it's a vector. Velocity, as the name suggests, it's speed and the sense of direction, so it's a vector. The work done is associated with the energy, and an energy does not require a sense of direction, it's a scalar. Okay, so simple things from class 11th physics, right? Moving further to next question. So this here is our question and there is a diagram associated. So let's say this is our diagram. Okay. Identify the following vectors. So first are co-initial. So co-initial vectors starts from the same point. So are there any vectors that start from the same point? So if I look at this point, A vector starts from this and B vector starts from this. From this point, no two vectors start. From this point, C vector start but not B. And from this vector, B vector starts but not A. So okay, so A vector and D vector are co-initial. So remember, same initial point, right? Second is which of these are equal vectors? So equal vectors has a definition, right? Same magnitude and same direction. So are any of these vectors does any of these vectors look like they have same magnitude and same direction? Well, if I talk about the direction, A vector and C vector may fit our criteria, and also B vector and D vector. But if you look at A vector, uh, let me take this. A vector starts from this point uh, and ends up here at this point, and but C vector starts from this point and ends up here. So they have the opposite direction. So A and C are opposite vectors, right? Negative of each other, right? So these will not be equal. But on the other hand, B vector and D vector, if you look them carefully, B vector starts from here and ends up here. D vector starts from here and ends up here. They have same length and they have the same direction. So yes, so B and D vectors are equal vectors, right? So third is collinear but not equal. Collinear but not equal. So collinear vectors have a definition. They are parallel or anti-parallel, right? Okay, they have basically same direction or opposite direction. Length पे कोई restriction नहीं. So again, A and C fit our description and B and D. But B and D are equal vectors, right? So A and C are our collinear vectors. So look, if you look into the diagram, let me mark them here. So A vector is Okay, so is let me change the color here. So A vector is this vector here, and C vector is this vector here. So they have equal lengths, but they have opposite directions. Since have opposite direction, they are not equal vectors. And since they have opposite direction, they are collinear. So, these two fit our criteria, and I will say A and C vectors are collinear but not equal. Okay. Collinear but not equal. Okay. So answer the following questions as true or false. So are A vector and minus A vector collinear? True. So let's say this is A vector. Minus of A vector is nothing but a vector starting from the head of the A to the tail of A, right? So it has the opposite direction. So and they are collinear, yes, because the only thing required for collinear is there should be parallel or anti-parallel. Two collinear vectors are always equal in magnitude. Is that true? False. So collinear vectors can be of different length only, or they can be opposite in direction also, but nobody is saying they have to have equal length, right? So only restriction is they need to be parallel. So this statement is false. Two vectors having same magnitude are collinear. So is this true? अगर दो चीजों का लेंथ बराबर है तो वो कोलिनियर होंगे. This is also false. Why? Let's say this vector and this vector, right? Let's say they have same magnitude, right? ठीक है, इसका भी लेंथ क्या है? Let's say L है, इसका भी लेंथ L है, but they do not have the same or opposite direction. So this statement also becomes false. So because they have same magnitude, but this does not mean they have same direction, but not same direction. Same or opposite, right? Okay. Same or opposite. So basically they are not parallel. Okay. So two collinear vectors having same magnitude are equal. Is this true? Well, let's take the first question and draw that again. A vector and minus A vector. So these are collinear, right? Okay. But they are equal? No, they are negative of each other. So this statement here is also false. So these are two vectors, since mod of A vector, right, is equal to mod of minus A. But A vector and minus A vector have opposite directions, right? Hence they are not equal. So this is an example of fourth part. So this statement is also false. So okay. So is there are there any more questions? No. So I'll be recording more lectures and putting them here only, and you can always go below in the description for the PDF version of the notes. So I will print this out and keep it as a Google Drive link there. So thank you for joining me. Hopefully I'll see you again.